What's up, PreCalc? Here we are with 1.4. So this note packet, I just printed this off of Schoology. And so it should be the same one as off of Schoology if you want to follow along with that. Or if you want to pause and go print that off. Otherwise, we're just going to walk through this. And we're going to start off by talking about functions. So a function is a function f from set A to set B is a relation that assigns each element x in the set A to one element y in the set B. So each x only goes to one y value. The set A would be the domain or the inputs, and the set B would be the range or the outputs. Okay? Let's see if I can zoom in anymore. To understand this definition, we're going to look at a picture of it for temperatures. So time of day, 1. It looks to be like that's 9. So we got the points written down here separately. So it looks like all the screen grabs from the textbook didn't necessarily work out the best, but it's better than nothing. So 1 is going to 9 degrees Celsius. Okay, there. 4 is going to 15 degrees, and 3 is going to 15 degrees. So it's okay that two different x's are going to one y value, but one x can't go to two different y values. If you're thinking about this on a graph, it's okay if it's 3, 15, 4, 15, because that's going to pass the vertical line test. But if we had 3, 15, and 3, 17, that's no good. That does not pass the vertical line test. Okay, characteristics of a function from set A to set B. Each element in A must be matched to something in B. Some elements in B don't have to be matched. All right, so all of these over here in the domain have to have a partner. You might not use some of the possible answers from the range, though. 2 or more elements in A may go to the same B. All right. But an element in A, the domains, cannot be matched with 2 different ones in B. So we can't have 4 going to 2 different y values over here. Basically, guys, x's can't repeat. All right, you can't have 4, 15, 4, 16. That's where you get into trouble. Okay, we can represent functions verbally, numerically, graphically, algebraically. To determine whether or not a relation is a function, you must decide whether each input value is matched with exactly one output. If any input is matched with 2 or more outputs, it's not a function. All right, so let's take a look at example 1. 1a. X's, Y's, inputs, outputs. All right, so right away we got our error here. We can't have 2 going with 11 and 10. Over here graphically, we seem to be okay. Each x has its own y value. It would pass the vertical line test. All right. In algebra, it's more common to represent functions by equations or formulas involving 2 variables. Y equals x squared. That's going to be our parabola over here. X is the independent, y is the dependent. The domain of the function is the set of all the values taken on by the independent variable x. The range is your dependent variable y. All right, so let's see what else we got. Is this a function? X squared plus y squared equals 8. All right, so from geometry, you should remember that this is an equation of a circle. And thinking graphically, a circle does not pass the vertical line test, not a function. Algebraically, if we would solve for y, so y squared equals 8 minus x squared, square root both sides, y equals plus or minus the square root. Okay, so plus or minus. Okay, so if x is 4, well, that's a bad one to pick. What if x is 1? All right, 1. So 1 squared is 1, 8 minus 1 is 7. So y would be plus the square root of 7 or minus the square root of 7. So we'd have 1 comma square root of 7, and 1 comma negative square root of 7. So 1 is going to go to 2 different values. That's no good. Not sure what this is. We'll kind of skip that. Looks like something didn't transfer very well. Let f of x equal 10 minus 3x squared and find the following. Okay? So a little function notation. What if I put 2 in here? 2 squared is 4. 3 times 4 is 12. 10 minus 12, we're going to get negative 2 on that one. Put negative 4 in. Negative 4 squared is positive 16. Times 3, we got 48. 10 minus 48, negative 38. Okay? Fun one here, x minus 1. All right? Hey, it's pre-calculus, but you guys are still going to make this silly mistake of x squared 1. Okay? X minus 1 parentheses squared, you might as well just write it out twice. X minus 1, and FOIL it out. That's what it means, x minus 1 times itself. Okay, so we got 10 minus 3 times, you can do this over here. This is going to be x squared minus 2x, that's the part you're going to forget, plus 1. Now distribute, tricky, we got a minus 3 times, so this minus is actually going to go with the 3. Minus 3x squared plus 6x, negative, minus 3. Put the 10 and the minus 3 together, we're finishing out at negative 3x squared plus 6x plus 7. Neato. Okay. A function defined by 2 or more equations over a specified domain is called a piecewise function because you got multiple pieces. All right, evaluate for negative 1, 0, and 1. Negative 1, which piece is it going to? Less than 0, greater than or equal to 0. Negative 1 is less than 0, so we're going to put it in here. Negative 1 squared is positive 1, plus 1 equals 2. So we're going to get negative 1 going with 2. 0. That's the tricky one because that's the split point. 0, 0. Which one does it go with? Less than or greater than or equal to? Or equal to. We're putting it here. So 0 goes in this branch. 0 minus 1 is negative 1. So my point there would be 0 comma negative 1. 1. Definitely bigger than 0, so we're using this one again. 1 minus 1 is 0. All right, example 6. Find all values of x for which f of x equals g of x. We're putting 2 functions equal to each other. So when does 6x squared equal x squared minus 14x plus 3? All right, so let's get everything onto one side. All right, I could subtract the 6x squared, and then we're going to have a negative x squared over here, or I can kind of move everything else over. You don't want to have a negative x squared. It might be easier to subtract over and then change all the signs, whatever you want to do. I think I'm going to move everything over here. So I'm going to minus x squared, then we're going to plus 14x and minus 3. So now we're going to have 5x squared plus 14x minus 3 equals 0. All right, now we're to a factoring problem. And now we have a factoring problem. Okay, different teachers have different ways to organize these. All right, you got a number in front, so whenever you have a number in the front, front times back, what multiplies to negative 15 and adds, to 14. How about positive 15 times a negative 1? Negative 15 and positive 15 plus negative 1 is 14. And now you got to go back through and divide by your front number. 5, 5. So this is a nice one. This is going to be 3x plus 3. This one's a fraction, negative 1/5. Can't reduce it anymore, so the bottom slides up in front, 5x, and we still have our minus 1. All right, so you might have learned a different way to factor, especially with numbers in front. That's fine. I don't care. Use whichever way works for you, as long as it's, there's a work shown and your answer's right. I don't get too hung up on that you did it my way. All right. So what makes each one equal 0? Negative 3 or positive 1/5. So those are the two values of x, which would make f of x equal g of x. The domain of a function can be described explicitly, which it just tells you, like x is greater than or equal to 0, or it can be implied by the expression used to define the function. The implied domain is a set of all real numbers for which the expression is defined. For instance, we have 1 over x squared minus 4. Okay, it's implied that the bottom can't be 0. All right, you can't divide by 0, so that means that x can't be positive or negative 2. Because that would make the bottom undefined. Or it would make the function undefined because the bottom would be 0 and you can't divide by 0. Zoom out a little bit for us here. Okay. Another common type of implied domain is used to avoid even roots of negative numbers, right? No square roots of negative 3, fourth roots of negative 5, stuff like that, trying to avoid imaginary numbers. So for the function given by the square root of x, our domain is defined only for x is greater than or equal to 0. Okay, another way of expressing that is interval notation. 0 to infinity, bracket includes 0, parenthesis does not include infinity. You can't ever get to infinity, so that's why it's considered not including it. Okay, so here's a little chart, if you're looking at your notes, of kind of what interval notation would look like. It's just a little shorter than writing some of these out with inequality symbols. So between a and b, parenthesis a, comma b. All right, but now it's greater than or equal to. It's between a and b, including a and b, bracket, bracket. Not including one, but including the other. Not including a, including b. Includes a, does not include b. Okay, and this is where it gets a little bit longer, when it's just less than or greater than a number, because now you're actually writing two things. You're writing infinity and the number. Okay, you never include infinity, you can't get there, so that's why they have parentheses and not brackets. All right, well, what happened there? Lost it. All right, domain. So for this one, our domain, we got negative 3, negative 1, 0, 2, 4. Our x's, remember? Okay, domain here. This is going to be the implied one. It's all real numbers except, okay, you can write that out, or I'm just going to go with x is not equal to negative 5. Volume of a sphere. You're like, oh, any number would work in here, right? 4/3 pi r cubed. Any number is going to work in there. Okay, think about it. This is a real-world problem. Volume of a sphere. What radiuses or radii would you not have? All right, you don't have a sphere if your radius is 0. You also won't have a sphere if your radius is negative, at least not yet. We'll talk about negative radius later. So for now, our r's need to be greater than 0. All right, and for this one, the square root of 4 minus 3x. We're trying to avoid a square root of negative numbers, so I need 4 minus 3x to be greater than or equal to 0. Alright, so maybe, subtract the 4, negative 3x, greater than or equal to negative 4, divide by the negative 3. If you divide it by a negative, we flip our sign. Negative over negative is positive. Okay, so in order for us to keep this from being the square root of a negative, our x's, we actually would want negatives. That would keep us from having an overall negative answer under here. Okay, example 8. You are working in the marketing department for a soft drink company, experimenting with new can for iced tea, slightly narrower but taller than the standard can. For your experimental can, the ratio of the height to the radius is 4. So h would equal 4r, 4 times the radius, or h divided by your radius. I guess technically it's a ratio, would equal 4 to 1, or 4 over 1. Write the volume of the can is a function of radius r. Okay, so volume, think back to geometry, it's been a while. Volume of a cylinder, so the base of a cylinder is a circle, so pi r squared, and then it's a circle going straight up vertically, so times the height. Alright, so I kind of got us started here on this one. The ratio, h over r is 4 to 1. Well then, multiply this up, h is 4r. So I could put this in as 4r right here. So our volume would be 4 pi r squared times r is going to be r cubed. Alright, if we plug in 4r in there for h. B, write the volume of the can as a function of height h. Alright. So here we are again, pi r squared times h, but this time, so we had function of the radius r, so we had r's in here, we replaced the h. This time we want to go the other way around. We want the h's left in, so now we have to replace the r. Alright. So let's kind of, we were here, we got to here, now let's keep moving from this one. We want r by itself, so divide by 4. R would equal h over 4. I'm going to plug that in. V equals pi times h over 4 squared times h. So parentheses squared, we got pi, I'm losing it, sorry guys. Pi times h squared over 16 times another h. Pi times h cubed over 16. Alright. More fun, more fun. Last, well, I think it's a two-part problem, but still the last one. Alright, so this is kind of like the big deal. I said in class earlier that right away it's like Algebra 3. It's basically Algebra 2 all over again, but then you have a few small things that kind of go above and beyond what maybe you did before. So this is one of those things, the difference quotient. This is kind of actually a big deal on your journey towards calculus, and we're going to work with this again some more at the very end of the year. One of the basic definitions in calculus employs this ratio, f of x plus h minus f of x, all divided by h, assuming h is not 0. Alright, so our first example. For the function f of x equals x squared minus 2x plus 9, evaluate this. So our x is going to be 4, so we're finding it for at 4. Okay. So, if you do all this all at once, this gets a little messy on the top, and you can kind of lose signs and stuff. So especially your first couple times, I would really advise kind of breaking these apart, doing them separately over here on the side. So f of 4 plus h equals, so if we did that, so we're going to have 4 plus h squared minus 2 times 4 plus h. You're plugging all those 4 plus h in for all the x spots. Okay, so parentheses squared, again, don't square the first and just square the second and call it good. That's not how it goes. FOIL it out. Or it's first one squared, second one squared, and then in the middle, first times last times 2. So this is 16 plus 4, it's going to be 8h in the middle, plus h squared, negative 2 times here, so minus 8, minus 2h, and then we just have this plus 9. All right, putting our common things together, maybe rearrange it so the h squareds are in the front. So we got our h squared there. Regular h's, what do we got? We got a 8h and a negative 2h, so that's going to be plus 6h for the regular h's. What else we got here? Regular 16, a positive 16, and negative 8, so that's down to positive 8. And plus 9 more makes plus 17. So we got that. We're just going to save that for a little bit. And then let's find what actual f of 4 is. Four squared minus 2 times 4 plus 9. So we got 16 minus 8 plus 9. That looks familiar, doesn't it? 16 minus 8 plus 9, that should be 17. Yep. All right. So we got the two pieces done. So let's plug it in all together. So f of 4 plus h, that's this part. Minus this part, 17. See, a lot of kids will lose that negative sign if they don't do it piece minus piece. So minus 17 all over h. And this is what should happen, guys, if you do it right. If you do it right, this is what should happen. Okay? These pieces are going to cancel out. These both have an h, so we should be able to factor out the h. All right, over h, and now this h cancels off the bottom, and our final answer is h plus 6. All right, what this is going to be is a formula for slope. Okay, that's what this is going to be. It's the same as finding the slope between 2 points. So this is like the slope equation for this function. All right, guys. Last piece of it, and then we'll be done for this video. What if, okay, so this one, f of x equals x squared minus 4x plus 7. Now it's not just giving us a straight up number, okay, it's just giving us just a general x. And we want to find the difference quotient for this. We weren't given a specific number to put in. Okay? So we really only need to do the f of x plus h part, because minus f of x is just going to be minus that whole thing. So I'm going to put x plus h over here. So we got x plus h squared minus 4 times x plus h plus 7. All right? So hopefully we can get to a point where we can do these in our head, x squared, h squared, multiply these two together and double it. So plus 2xh plus h squared minus 4x minus 4h plus 7. And I'm not seeing anything to put together, so this is just going to stay like a big mess. All right, bring it over here. So that is this first part. Yeah, it's a big mess. Minus f of x, so minus the whole thing. So you got to put parentheses around that, and then distribute that negative sign. All right, so I'm going to be distributing this negative sign into all those. And, I mean, if we were being super neat and tidy, we would do another line. But I think I'm going to save some space here. And we're just going to do negative x squared plus 4x on the top, and then the minus 7. So I just distributed that negative. So we got x squared. This is all over h. X squared minus x squared gone. Minus 4x plus 4x gone. Minus 7 plus 7. So your little halfway checkpoint here is all the stuff should drop out except for the things that have an h. So now we've got h squared plus 2xh minus 4h over h. Factor an h out in the front, on the top. Boom, boom. All right, and now this is your difference quotient. Okay, it gets really long and sloppy there, guys. It gets tough to keep track of all the negatives, but you can do it. Okay, there's a quick summary of all the stuff we talked about, like terminology down there. You can read that if you want on the note packet posted to Schoology. Otherwise, that should get you going here on the first lesson. A lot of review stuff. This one was probably the hardest thing they needed to do. Thanks a lot, guys. Good luck.